What's up everyone, Patrick here, welcome back. Moving on to the next video dealing with triangles. So in this particular video, we're going to talk about the different cases that the circumcenter can take. So there's not really going to be any algebra in this video. I'm going to explain all of this through diagrams. And we've gone through videos before of where we've had to find the circumcenter, but we didn't really go through the different cases that can come about with the different triangles. And so that's what we're going to cover in this particular video. So as a quick review, what is the circumcenter? Well, it's basically the point of intersection of all of the right or perpendicular bisectors of the triangle, of the sides of the triangle. And the location of the circumcenter in reference to that triangle can vary depending on the type of triangle that you're dealing with. So the first kind of triangle is you can have an acute triangle, and that's when all of the angles are going to be less than 90 degrees. And so if we draw an acute triangle, let's say it looks something like that, and let's draw the right bisectors here. So remember, the right bisector, it's for each side we got to get the midpoints, and then it's going to be the perpendicular lines that go through those midpoints and are perpendicular to each of the sides. So over here, it would be like this line. Over here, it would be like this line. And then over here, it would be like that line right there. So if we shade these in, notice that they are all intersecting right there. All three are going to intersect at that same point, and that point right there is the circumcenter. So from this diagram, notice that when you're dealing with an acute triangle, the circumcenter, it's going to be inside the triangle. All right, and usually that's the most common case that's shown in textbooks. When you see a diagram, usually the circumcenter is going to be shown inside the triangle, but that's not the only case that can come about. But if you are dealing with an acute triangle, it's always, the circumcenter is always going to be inside that triangle. Now the next case that can come up is if you're dealing with a right triangle. Okay, if you're dealing with a right triangle, it means that one of the angles is 90 degrees. So if we draw that, let me try to draw this as to scale as possible. So if we just draw a 90-degree right triangle like that, let's find the right bisectors here and see where they're going to intersect on the diagram. So the midpoint of this side would be over here, about the midpoint of this side, let's say it's like over here, and then the midpoint of the hypotenuse, let's say that's going to be like over here. So notice that a line going through this midpoint and perpendicular to this side, it's actually just going to be parallel to this side. Right? And then a line going through this point and perpendicular to this side is just going to look, it's just going to be a line like that. It's actually always going to be parallel to this side. And then the perpendicular bisector going through this point and then perpendicular to this side, it's going to look something like that. So if we shade these in, and then we got this one right there, right? This is going to be perpendicular to that, that, and that right there. So notice that where are all of them intersecting? Well, they're all intersecting at the circumcenter, and notice that the circumcenter, it's actually going to be on the hypotenuse of the right triangle. We're actually going to go through a video with actual coordinates of where we have to find the circumcenter on a right triangle and then confirm that it's actually going to be on the hypotenuse. But just in general, when you're dealing with a right triangle, the circumcenter, it's always going to be on the hypotenuse, and actually more specifically, it's going to be the midpoint of the hypotenuse, right? Because notice that this perpendicular bisector, it's going through that midpoint on the hypotenuse. Okay, so if you're dealing with a right triangle, the circumcenter is going to be on the midpoint of the hypotenuse. Okay, and as I mentioned, we're going to go through a future video of where we go into that in more depth. We're going to deal with actual coordinates, and then we're going to confirm that the circumcenter is actually going to be there. All right, but just in general, that's what happens. And then the third case, the final case, is if you have an obtuse triangle. So remember what kind of triangle is that? It means that one of the angles is going to be greater than 90 degrees. So if we draw an obtuse triangle, let's say we have a side like this, and then to create an obtuse angle here, I'm going to slant the other side to maybe like, let's say over here, like that. And then that longest side is maybe going to look something like that. Right? That's an example of an obtuse triangle. You could draw any triangle here, and then the case that's going to happen with the circumcenter is going to work for any obtuse triangle. So from here, let's see what happens if we draw the right bisector. So we got to get the midpoints of each of these sides. So the midpoint is there, midpoint is approximately there, and then we got the midpoint, let's say like over here. What's going to happen, just as a spoiler alert, is that the circumcenter is actually going to be outside of the triangle. So hopefully these meet at the same point. If you draw these to scale, then they will meet. It's just that's the challenge, drawing them to scale. So hopefully, yeah, it looks pretty good to me. Right? So the right bisector of this side looks like that. The right bisector of this side, it looks like that. Right? We got 90, 90, and then the right bisector of this side looks like that. So maybe not the best to scale, but nevertheless, if you do draw a diagram with a ruler and to scale an obtuse triangle, the circumcenter, where those right bisectors are going to intersect, it's going to be outside of the triangle. So the circumcenter with an obtuse triangle, it's always going to be outside of the triangle. Okay, so those are the three general cases for where a circumcenter can be. Now, one thing I actually want to go over, there are a couple of subcases in each of these that sometimes you may run into. Some textbooks might mention it, some teachers might mention it, some may not. Is if you're dealing with isosceles triangles in these three cases. So notice you can have an isosceles acute triangle, you can have an isosceles right triangle, you can have an isosceles obtuse triangle. And the only thing that happens if you have an isosceles triangle, so let's say that this side and this side are the same, it means that the side that is not equal, right, the unequal side, which is this side over here, the right bisector of that side, it's always going to go through that vertex that attaches those two equal sides, right? So it's just kind of a subcase. The circumcenter is still going to be within the triangle, and that's mainly what this video is about, but I just kind of want to add this side note in case that you run into this this rule here. So if you're dealing with an isosceles acute triangle, this right bisector here, okay, maybe don't draw it on the same diagram, maybe draw like a separate diagram and you could just write it as a subcase. This right bisector, it's going to go through that vertex right here. Okay, and then if you have an isosceles right triangle, so notice here, notice how this side, it's kind of longer than this side. So this here is a scalene right triangle, or all of the sides are going to be different. So notice that this right bisector, it's actually not going through this vertex, right? If we extend it, It's going through like right there. But if this was an isosceles right triangle of this side and this side are equal, then what's going to happen is that right bisector of that opposite side of the hypotenuse, this right here, it's going to go through that vertex right there. Then same thing over here. In this particular diagram, this is a scalene obtuse triangle, right? All three sides have different lengths. And so notice that this right bisector, it's not going through that point. But if this was an isosceles obtuse triangle, so let's say this side and this side were the same, then this right bisector of that opposite side would be going through that vertex of where the two equal sides meet. All right, so just wanted to mention that subcase. Again, that's not mainly what this video is about, but you may run into something like that where they say first maybe confirm that a triangle is isosceles. You find all three sides. If two of them are equal, it's an isosceles triangle. And then they'll say confirm that this right bisector goes through that vertex, for example. And we've gone through how to confirm that a point is on a line, right? You would find the right bisector here, and then you would just plug in that point. You would plug in the x value and make sure you get the corresponding y value of that vertex. So that's a potential question that can come up. Again, that's not what the video is mainly about. The three different cases of the circumcenter in general, if you have an acute triangle, it's going to be inside the triangle. If you have a right triangle, it's going to be on the midpoint of the hypotenuse. And if you have an obtuse triangle, the circumcenter is going to be outside of the triangle.